We're solving problem 25 from the AMC 10A from 2017. How many integers between 100 and 999 inclusive have the property that some permutation of its digits is a multiple of 11 between 100 and 999? For example, both 121 and 211 have this property. So we want to find integers divisible by 11 between 100 and 999. The closest integer divisible by 11 is 11 times 10, or 110. And the one that's closest to 999 is 11 times 90, which is 990. Now, we want to find how much integers are in this total gap, I guess, in this group. So it's inclusive, so we do 90 minus 10 plus 1 gives us 81 integers. We have 81 integers, and now what if we have we start counting cases now. If you might think that it's 81 integers times 6 because there's 6 ways to arrange a 3-digit number, but no, it's not, because if there were a 0 in the number, one of the ways would have a 0 in front, and then it would be a 2-digit number, not a 3-digit number. So if there's a 0 and a divisor, or 2 numbers, this one's out. Now what if it's some number, call it n, and then 0? Well, it's like all these cases, except we see here that there's 9 cases, because there's 11 times 10, 11 times 20, ... until 11 times 90. So, and now we multiply by 2, because that's how much ways you can rearrange it without the 0 being in front, which is 18. Alright, so now we can start counting our first real weird case, which is, let's just A, B, A. They're all real numbers. We count 121. We count 242. We count 363. 484. Now we can't use 5 as our first and last number, because then the middle number, in this case B, would be 10, which is not a digit. So and this is made true by the divisible by 11 rule. 4 minus 8 plus 4 is 0, all the way like that. And now we have to go backwards. The divisibility rule says 4 minus 8 plus 4 is 0 or divisible by 11. So we go the divisible by 11 right now. 6, 1, 6, and then we get 7. So 6, 1, 6 is 12 minus 1 is 11, and then 14 minus 3 is 11, so 7, 3, 7. Then this is 8, 5, 8, and then this is 9, 7, 9. So in total here, there are, when we count these up, there are 8 integers. 8 times 3 is 24, because that's how much ways you can arrange it. Now, alright, we have that. So, now we can count. What if it was in a A, O, B, and this is a 0? We find that there are 8 integers coming from here using these methods before, simply listing them out. But we don't add 8. Instead, since they're paired up, we do 4 times 4, which is 16. And so, we almost have all of our numbers in motion. We just need to count A, B, C, which is, what we can do here is we add these up, and then we subtract that from 81, and then we get that there's 56 integers like this, and then there's also CBA. So in this case, well, not in this case, here we have to multiply by 3 to get 168. And adding all these underlined numbers up, these underlined numbers mean how much integers there are. Adding all them up, we get that our answer is 226, and we are done.